If you have an infinite flower vase, can put countless balls inside. Each ball has a unique number. Now you need to within the 1 minute. In the first 30 seconds, we'll put the first to the 10th ball. Then take the first ball. The 15 seconds, put the 11th to the 20th ball. Then take the second ball. According to the same logic, the next 7.5 seconds, put the 21st, the 30th ball. Then take third ball. Every time is of the previous one. Every time you need to, and then take away the smallest one, so it's pushing. So the question is, how at noon? The question is not over yet. If it is still the same rule, we still put in 10 balls, but this time we will take away the biggest one. How at noon?
This is a hypothetical question. So let's assume that your hand is super fast. You can keep playing ball without resting. Let's talk the answer first. If you take the ball at 12 o'clock, there will be countless balls. If you take the smallest number of balls, there will be only one left. Why it be? As taking 10 balls and taking one, end result will be so different. According to normal logic, whether you take the smallest of or the largest, you take one. So every time you take out a number, it's always of you put in. Since you can operate countless times, shouldn't there be countless balls? But if we change the logic, because each step is being reduced by, so you will have unlimited opportunities to take ball and play ball. Since the balls or balls is limited, doesn't that mean that every ball will have a chance to taken away? Fact. This problem is called the Littlewood theory, or the Vase theory. It was first mathematician John Littlewood came in 1953. The key to is how you took the ball out. Let's take simple example. Suppose you have a big group of cows, you and a lot of milk tea. To determine whether the cow more milk tea, or simplest way is to each cow a cup of milk tea. If they're a cow that hasn't had milk tea, means that the number is the milk tea. If they're milk tea left, it means that the number of is then the number. But if every cow has a cup milk tea, it can only prove that the two boxes is the same. In fact, this is the mathematical analysis to determine the summing sizes.
If each element can find another sum, then these two summing is the same. And this idea can only determine a finite summing, but also the number infinite summing. For example, suppose sum A starts from 1 to infinity, and sum B starts from 101 to infinity.
Fact. You may think that because sum B is sum A,
so the size of different.
But if we compare you will find that the of A and B is a pair,
and 2 and 102 are so similar. In this way, each number can find the corresponding number, so that these two sum is the same.
And this is the key to because every time you take away the smallest ball,
every ball will turn to it was taken away. So at 12 o'clock, there will be left, but if you take away the biggest ball, then except for 10 times, there will be corresponding step to take away. So at 12 o'clock, there will be a lot of balls. What if it's random? In fact, the probability almost all the balls will be taken away, so the end is nothing left. So how many balls? It is completely different from whether the ball can establish a corresponding relationship. And question is, if a minute can be cut infinitely, can the moment come? Since is a factor that is infinitely close but never reached, do we still have chance to calculate how the vase?